Good afternoon to all. I am Lalita, Assistant Professor of Dr. SNS Rajlakshmi College of Arts and Science, Department of Computer Applications. In this video, we are discussing about edge virtualization and fog computing. In this video, we are discussing about edge virtualization and fog computing. Let's go to the video. Definition: the process of running multiple virtual machines or container on the hardware located on the edge of the network. Edge means near the data. Edge means near the data stores where the decentralized data center. The goal to bring a cloud-like capabilities and compute storages physically closer to the IoT device. The process running the multiple virtual machines is container hardware located on the edge. What is fog computing? A centralized computing infrastructure where data, compute, store, and applications are located between the data source and cloud. Centralized data means it's like a data warehouse, and the data warehouse, how we can store the data and retrieve the information. Likewise, the data can compute storage and appliance on the located between the data sources and the cloud. The fog metaphors: if the cloud is so far away the sky. Fog is cloud that closer to the cloud. Fog is the cloud that is closer to the ground. How it's work? It's act as the horizontal layer that distribute resources across the network to reduce the amount of data sent to the main cloud. Edge and fog computing. What are the key difference between edge and cloud fog computing? Edge computing is the processing happens directly on the devices or local gateway. It is like a smart camera or an industrial controller. It is localized data transfers. That means it can detect where the cloud computing near the data source, near the source, where the users can detect near the source and they can access the local gateway. Fog computing is processing happen on local area network like a LAN. It involves the multiple node communicating each others. It is their network wide. Analog, which is a sensor making is an instant decisions to stop emissions. Through the edge computing, it means near the source, so sensor easily detect the decision when the machine will be stopped and when the machine will be stopped. Fog is the group of sensors and routers, the factory floor, coordinating to optimize the entire productions on the line. Key benefits of edge and fog virtualizations: ultra low latency and bandwidth efficiency. Ultra low latency is a crucial time sensitive app like autonomous vehicles or remote surveillance where the milliseconds matter. Ultra low latency is a crucial time applications when the applications should make decision immediately, or it make the adapt the data or adapt our service immediately, like a autonomous vehicle. When the autonomous vehicles move on the road, it should be make a decision in the fraction of the second, otherwise the accident will be occur, like so that it is the ultra low latency. Bandwidth efficiency is reduced the network cognitions by processing and filtering data logically when the essential summarized data is sent to the cloud. Enhance the security. Sensitive data can be processed and stored logically. It's reduce the risk of interceptions during the transits to the public cloud. In the sensitive data can proceed the data, reducing the risk of during the transmit to the public cloud. Offline functionality: the applications can continue to run even the primary internet connection to the cloud lost. The application can continue when even the network is lost. then only our service will be provided to the client or provided to the machines uh, parallelly. Otherwise, the machines will uh, stop the machines will accordingly. It is the interpretations of the transfers of public real world example. These are the real world examples how the edge computing and fog computing is act in the data. Smart city managing the traffic lights and emergency response system in real time using localized fog nodes. Using the fog nodes, they are managing the traffic lights and emergency system. Industry IoT system is provide the maintenance on factory floor where the machines deduct their own VR and TR. Autonomous vehicles can processing the gigabytes of sensor data instantly avoid collisions without waiting for the cloud response. Autonomous vehicles should respond immediately, so the gigabytes of sensor data we can use for the autonomous vehicle, so that we could not wait for the cloud. If we wait for the cloud response, it could not take a decisions on the next fraction of the seconds. So these are the real world example where the fog and cloud computing are act as. Thank you.